Namaste, welcome to Sthitaprajna channel, and you are watching a brand new playlist that I am just starting. This is our first video in it, which is for the machine learning basics theory. We are not going to do any practicals here. Maybe practicals, we already have some videos for practicals, which I will show later on, but this is going to be pure theory with real-time examples. So that is the kick of this playlist. So why am I making this playlist? Basically, I'm going to start the exam question analysis for the machine learning exam, AWS exam, which is MLS C01 specialty exam. And since the questions have these concepts, most of the people won't understand. So I thought, okay, so let's pick the concepts from those questions and make separate theory videos here. So instead of me explaining there, because some people are won't be interested in this because they already know this. So instead, I'm making separate videos so that people who are interested, they can come here and watch them, and then they can go ahead and watch or listen to the MLS exam question analysis. So I am not making this mandatory for everyone by adding that in those videos. So these will be separate videos. So here I'm going to post the topics that will be asked in the exam. Specific topics that are already asked in the exam, we will have here. Okay, that being said, let's not waste any time and jump into this. And the first video is going to be about kNN algorithm or K nearest neighbors algorithm. So this is going to be introduction, not deep dive, um, but we'll just talk what it is at a high level, and then we'll look at real-time examples, theoretically how you would or how this algorithm would solve a particular problem. What is the k nearest neighbors algorithm? The kNN algorithm is a simple yet powerful supervised learning algorithm. So if you don't know what supervised learning algorithm, then you have unsupervised learning algorithm. I posted, I guess yesterday on YouTube, on our channel, I posted a post that listed what are the things that you need to watch before coming here. I will put that uh, again, the contents that I posted there in the description of this video. I would want you to watch those videos before even coming here. Okay, there we explained what a supervised learning is, unsupervised learning, reinforcement learning, etc. So go watch it there. So this one, which is used for classification and regression tasks. So kNN used for classification and then regression tasks. We have a couple of more videos coming along where we will explain classification and regression as well. But basically, kNN algorithm is used for classification. It's a supervised. If somebody asked, is it a supervised or unsupervised? You will say it is a supervised algorithm. Supervised algorithm. And this is used for what? Classification and regression. It works by comparing a new data point with existing data points, which is nothing but our training data, and assigning a category or predicting a value based on the majority class or average of the nearest k neighbors. So that's the core idea. Amazon SageMaker. Now we are going to use kNN in SageMaker. Why? Because this is pretty much what it's an AWS exam. So obviously we are going to use SageMaker. If you don't know what SageMaker is, we have a video on that as well explaining the SageMaker. This provides a built-in implementation of the kNN algorithm that is optimized for large-scale machine learning tasks, allowing users to train models on vast data set with high efficiency. That's what, in a nutshell, what SageMaker is. But how does the kNN work? Well, it has two steps. First one is the training phase. Okay. In the training phase, the kNN algorithm doesn't explicitly train in the traditional sense like other machine learning algorithms. Instead, it simply stores the entire training data set. That's what it does in the training phase. What does it do? It stores the entire training data set. It doesn't train anything. And then in the prediction phase, when a new data point is presented for classification or regression, the algorithm does few things. What? The first thing is it calculates the distance. It measures the distance between new data point and all the data points in the training data set. Common distance metrics include Euclidean, Manhattan, and Minkowski distances. And then after calculating the distance, it selects the k nearest neighbors. How does it do it? It identifies the k closest data points or neighbors based on the calculated distances, and it then makes a prediction. How does it do it? For classification, the algorithm assigns the new data point to the class most common among its k nearest neighbors. And in the regression, the algorithm predicts the value for the new data point by averaging the values of its k nearest neighbors. So this is theoretically what it does. We are going to look with an example next, but that's how it is. So in the prediction phase, you have calculating the distance, then selecting the k nearest neighbors, and depending on whether it is classification or regression, it does two things. So what are the key features of SageMaker kNN? Okay, so scalability. It's optimized for handling large data sets. SageMaker's kNN implementation is scalable and it can handle millions of data points efficiently. And when you consider about performance, it utilizes advanced indexing techniques like approximate nearest neighbors to speed up the process of finding the nearest neighbors. And flexibility, it supports various distance metrics. We have mentioned three of them, which can be selected based on the specific characteristics of the data set. Now that's theory. If you didn't understand, don't worry about it. Sometimes when you explain something with an example, you will understand more. Some real life examples include customer segmentation. Let's say there is a retail company which wants to segment its customer into different groups based on purchasing behavior. So how kNN is used here? By using kNN, the company can classify new customers into existing segments based on their shopping habits. For example, how frequently they are purchasing, how much average spend they are putting there by comparing them to the nearest existing customer profiles. And what is the outcome after using this? Targeted marketing campaigns can be created for each customer segment, improving customer engagement and sales. And another example is anomaly detection in network security. Okay, what is the example here? Detecting unusual network activity that might indicate a security breach. By analyzing network traffic patterns, kNN can identify potential anomalies by comparing current activity with historical activity. You are seeing that, right? Existing new data set points with existing data points. If the current activity deviates significantly from the norm, which is the nearest neighbors, it is flagged as suspicion. What is the outcome? Early detection of potential security threats, allowing the proactive measures to be taken. And another one is recommendation systems. Everyone might have already known this. Recommending movies to users based on their viewing history, something that Netflix does. How does it do? By comparing a user's viewing history with other users who have similar tastes, which are considered as nearest neighbors. kNN can recommend movies that are popular among those neighbors. So you are every day seeing this in action with Netflix. Outcome is personalized recommendations that improve user engagement and satisfaction. So these are some examples. There are plenty of them. But what are the advantages of using kNN in SageMaker? kNN is straightforward to understand and implement, making it an excellent choice for beginners and for situations where interpretability is important. Since kNN doesn't require a traditional training phase, it can be quickly deployed once the data is available. And it can be used for both classification and regression tasks, making it a flexible choice for a wide range of applications. And remember these considerations when using kNN. While SageMaker optimizes kNN for large-scale tasks, the algorithm can still be computationally expensive, especially as the size of the dataset grows. And the choice of k, which is the number of neighbors, can significantly impact the performance of the model. Too small a k might make the model sensitive to noise, while too large a k might dilute the prediction accuracy. Okay, so keep those things in mind. Now, these are some things about kNN. Now let's learn or let's go through step by step how kNN would work using a scenario. What is the scenario we are going to learn about? Classifying clothing images. Okay, so that's our scenario. Imagine you are developing a system for an e-commerce website that needs to automatically classify images of clothing into categories. And what are those categories? They might be, let's say, t-shirt, dress, and pants, etc. You can have many. You have a data set of labeled images where each image is already categorized. Now, when a new image comes in, your goal is to predict its category using the kNN algorithm. Got it? That's the classification. Remember, we said using kNN you can do two things. One of them is classification, which is what we are going to do here. So what will you do? Step one. Step one is dataset preparation. You start with a dataset of images where each image is labeled with its category, like these categories. Each image is represented as a vector of features. Vector is nothing but a list. These features might include color histograms, textures, edges, or more sophisticated representations like the output from a convolutional neural network or CNN in short, which we'll talk about in one of the other video. For simplicity, let's assume each image is represented by a vector of two features in our case, which is going to be color and texture. Okay. Now, once you do that, you are going to select a value for k, which represents the number of nearest neighbor to consider. For example, before considering whether the new image you added is a t-shirt, how many old data points that are nearest to you you want to consider. Okay, remember the more number you use, the more it is going to be impacted. So you need to be very careful what value you give for key. So here in our case, what are we going to do? We are going to pick k equals 3, and as a rule of thumb, usually they pick k equal to 5, but in this case I don't want to list too many examples here, so I am going to pick k as 3. Now let's suppose we have a small data set of clothing images represented by numerical features. How would it be? So let's say image ID is 1, 2, 3, 4, and 5, and then my feature 1 is color. Let's say this is 0.8, 0.4, 0.5, 0.9, and 0.2. And then feature 2 is what? Texture. Right? That's the feature of my clothes. Based on that, I want to classify them. 0.6, 0.7, 0.5, 0.4, and 0.8. Now, finally, category, which is this is something that I already have, my history or existing data points. So this one I consider a t-shirt, and this one I consider as a dress, pant, t-shirt, and dress. When a new image is presented for classification, the algorithm extracts its features and compares them to the features of all images in the training dataset. The comparison is based on distance metric. For example, we have mentioned three distance algorithms. For example, Euclidean, which measures how similar the new image is to each image in the dataset. Okay, so these are our existing image IDs. Now a new image came. Okay, you can put that new image as 6 here. And what are the features of this new image? I have color is 0.07, and then the texture is 0.5. Now we don't know whether it is a dress or t-shirt or pant. That's what our algorithm, we want our algorithm to figure it out. Then the distance calculation happens. So what does the algorithm do? It calculates the distance between new image and every image in the training data set. For instance, we have our features 0.7 and 0.5. So what is the distance formula? If you have learned it in geometry, I guess you should have already known this one. x2 minus y2 whole square plus so on and so forth. So this is how you find, I guess, distance between 2 points in, right? This is what Euclidean distance. I don't know if I'm pronouncing it right or wrong, but this is how you do it. Now we have these many points. I will just show you for 1 or 2 points, and then you can imagine how that calculation is going to happen. Okay, so this is our x1, x2, and this will be y1, y2 for the first one. This will be y1, y2 for the second one, so on and so forth. So in this case, this is it. Now, what are you going to do? X1 is 0.7, not this one, minus what is y1? In the first one, it's 0.8 whole square plus x2 is 0.5 minus y2 is 0.6 whole square, this one. So when you calculate this, approximately it will become 0.141. Okay, so let me put it here, 0.141 for the first one. I mean, we are calculating what? The distance between our new image and each one of these images. And this will be approximately 361. This will be 0.2 and this will be 0.224 and finally this will be 0.583. And these are ours. Then sort it out because nearest means it will be closest to you. So the first one, when you sort it out, this will be then top and then you will have point to this. Why only 3? Because I said k only 3, so I'm only going to consider 3 of this. So these are the my nearest ones to the new image. How far they are. These are my neighbors. Correct? For classification, the algorithm looks at the categories of these k nearest neighbors. It uses a majority voting mechanism. The new image is assigned to the category that appears most frequently among the k neighbors. For instance, if 3 out of 5 neighbors are t-shirts and 2 are dresses, the new image is classified as a t-shirt. Now if you look at these ones, so point 1 which is image 1 which is a t-shirt, point 2 which was it is a dress, and this one is image 4 which is t-shirt. So 2 out of 3 are t-shirts. So now what will my new image be classified as? As a t-shirt. That's how it does it. Now this is all good, but if I have to put this on a graph, let me see, let me put it here. Okay, so let's assume this is my graph, and then let's say I have point 2, point 3, point 4, 5, 6, 7, 8, and 9. This is 0 0.9, 0 0.2, 3, 4, 5, 6, 7, 8. Okay, let's do point 2, point 3, point 4. This is point 5, point 6, point 7, point 8. Okay, now on this side as well, let's do, this is 0 0.8, 0 0.6, 0 0.4, 0 0.2. Okay, now let's put our points on this graph. Now if you see, what do we have? We have 0.14 for image 1. Image 1 is what? This one, which is 0.8 here and 0.6 here, somewhere here it is. And this is 0.141 or image 1, however you want to put, it doesn't matter, you can put it. And then you have 0.4, 0.7, 0.4, 0.7 will come here, which is image 2. I will just put image 2, or you know what, let's be consistent, 361. And then 0.5, 0.5, which will be somewhere here, which is what, 0.2. And then 0.9, 0.4, and this will be 0.224. And finally we have 0.2, 0.6, 0.2, 0.6, which will be here, 0.583. And where is our actual image? 0.7 and 0.5, which is here. This is our image 0. You can consider the distance is 0. Now let's draw a line, this one here, and this one, this, and this one. So you can see how far they are, basically what I'm trying to say. So since these 3 are clearly the closest to our, these are our neighbors K3. If you consider 5, all 5 will be our neighbors. Got it? So basically this visualization shows how the kNN algorithm calculates distances and selects the nearest neighbors to classify the new images. So I hope it is clear, and if somebody asks what kNN does and how it does it, now you know an answer, don't you? So the example shows how kNN can be applied to classify images based on similarity to existing labeled images, making it a straightforward yet powerful tool in image classification tasks. How to choose the value of k in the kNN algorithm? That is a frequently asked question. The answer is there is no particular way of choosing the value k, but there are some common conventions to keep in mind. What are those? Choosing a very low value will most likely lead to inaccurate predictions. The commonly used value for k is 5. Always use an odd number as the value of k. Okay, so that's basically about kNN in a nutshell and the example. I hope you enjoyed the example. Okay, and the things you need to know from this video is kNN is a simple yet effective algorithm, and SageMaker's kNN implementation offers scalability, flexibility, and high performance, and it's suitable for a wide range of real-life applications. That's about this, and if you want me to make such videos more, then show that in the comments and likes. If not many people are interested, it will be very obvious for me based on the views, likes, and comments. I don't think I will spend extra time making this, because the reason I am spending time to make this is for you all. If you are not interested, then it doesn't make sense for me to put my time into this. Instead, I can just directly go with my exam question analysis. So let me know in the comments if you are interested. Then I will keep continue doing this. Otherwise, see you in the next one. Thank you very much for spending your time here. Don't forget to subscribe, like, and comment. And have a great day. See you in the next one. Peace out.